Okay, so we have the pleasure to have today Professor Yasser Abu Mustafa. So Professor Yasser doesn't really need any introduction, so I'll be quite brief. Professor Yasser is a professor of machine learning at Caltech and the chairman of machine learning consultancy. He has made significant contributions in many areas of machine learning and in teaching of machine learning. So he has received a lot of awards, teaching awards, and have written bestseller books on machine learning, which you probably are all aware of. And he's also the founding chairman of NeurIPS, or NIPS, which is the landmark conference of machine learning. So without further ado, Professor Yasser, please.
Thank you so much, Hussein, for the invitation and hospitality. I'm really happy to be here, and I thank the organizing committee for a very well-designed function. I find summer schools to be an excellent opportunity for people who are actually very talented to come together, know each other, and have a concentrated dose of something that carries a momentum afterwards. So I'm very happy to be part of that. So the title of my talk is Machine Learning Evolution and Revolution. Most people here are young people, so you probably have been exposed to the current wave of machine learning. So I'd like to put that experience in perspective, tell you what led to it, what's special about it, what are the challenges. So if you look at machine learning historically, there is a slow evolution and then a fairly sudden revolution that happened lately that led to basically machine learning being everywhere and being the technology that everybody should learn and apply regardless of what their domain of application is. So the construction of the talk is that first I'm going to start with the buzzwords, the terminology, because there are lots of words that are associated with machine learning, and I'd like to put them in perspective. And in the course of doing that, I will touch on what machine learning is, how it relates to intelligence, what is intelligence and what not. And then once I set that stage, I am going to give you a historical perspective, a short one, of the different stages that machine learning went through, and it will make you understand the particular ingredients that made the current wave such a success. Then I'm going to focus on what is the essence of machine learning, what is it about. And in the course of doing that, I am going to take the current model, which is the deep neural networks, and give you 6 ways to look at it that are actually, I find, to be very important and makes you understand why it is such a successful model nowadays. And I will touch on what are the ingredients of the current revolution. I mean, there's always progress, things are faster, you have more data, you have more interesting ideas, but there has to be some alignment of the stars, so to speak, in order to be able to have a huge impact like machine learning is having now. It's a revolution, and I'd like to tell you, identify what are the components that made it a revolution, and then move on to the challenges that we have, either technical challenges or sometimes social challenges that come with the advancement of such a field. So let me start with the buzzwords. You probably have seen all of these, and this is a technical audience, so they are not going to be alien to you, but there are lots of words going around, and sometimes they are the trendy terms, and sometimes they fall out of favor. And you can talk about AI, artificial intelligence, machine learning. Big data was big for some time. I don't think it's as big nowadays. And then there is data science, neural networks. How do these guys relate to each other? So here is the dictionary to sort of translate these words into one another. First thing to observe, which you probably realize by now, is that deep learning is neural networks. There's absolutely no difference other than the neural networks has more layers now. And historically, as you will see in a moment, the neural networks were very hot in the 1980s, and then they became not as hot. And it would have been a strategic mistake when the revival of neural networks happened to just call them neural networks again, because basically people in their mind will say, oh, we heard that before, okay? So it was actually a pretty ingenious idea to focus on one aspect of the network, which is the fact that it's deep. It's an important feature. But then you can call it, in the beginning, they would even call it deep learning without even mentioning the neural networks word, okay? And people who are not in the field will hear deep learning and they will think, it's deep learning type of thing. But it has nothing to do with that. It really has to do with architecture. And once the performance was proved, we came back to neural network to the level where people just call it neural networks nowadays or deep neural networks. So that is the first part of the terminology. Neural networks is one model of machine learning. So it's a proper subset of machine learning. Happens to be the hottest nowadays, and maybe it's here to stay and take over all other fields or other models, but it is really one of the models. There are other models that actually are very successful in other fields. Support vector machines remains very successful in financial applications, for example, but definitely neural networks have certain features that made them very flexible and very applicable, and I will touch on those reasons as we go. Then there is machine learning and artificial intelligence, and I think they are pretty much the same. They are not exactly the same. You can think of artificial intelligence as the goal and machine learning as the tool. But in reality, if you want to achieve artificial intelligence, you have to be able to learn. Learning has to be automated, and that is the subject of machine learning. And then for the other fields, I am just calling them all of them together. They are pretty much machine learning. You can think of like big data and data science and whatnot. Machine learning is the brain of those fields. Some of them need other aspects. For example, in big data, you need to be able to handle the data. So there's a question of database and whatnot. But the essence of it, of machine learning. So if you think of all of those, learning comes at the core of it. And this is the subject of this school and of the talk as well. OK. So now I would like to touch on intelligence because obviously the word artificial intelligence is more popular in the press because intelligence people can relate to. And I'd like to go through the levels of intelligence that we deal with in order to see what is achieved, what is not, etc. So let's consider the different levels that we as human beings associate with intelligence. First level is performing complex tasks. If you go to a movie and they want to tell you that a child is a genius, usually they demonstrate that by telling you that the child can multiply two big numbers in their head. That's a complex task. It's impressive to people. But in our mind, this is not really intelligence. It's a step. It becomes intelligence when you learn new skills. That is really the deciding factor for calling someone intelligent. Let's say you have a company and you want to hire someone, and you specify you want them to be able to program in Python, for example. That is the skill, the basic skill that they want. So they are performing complex tasks. That's how you hire them. After you hire them, if they learn on the job, that's good sign. They are good employee. Better yet, if you go to the next step, when they start innovating, they don't only learn the new skills, they are able to produce something novel, okay? That actually makes them a great employee. That's higher level of intelligence. And finally, a step that you don't want to reach necessarily, but it's the next step on the scale of intelligence, is that they take over. After they learn all of this, they go and start their own company and compete with you. Okay? Now, if you look at artificial intelligence, people have the same thoughts. You start with performing complex tasks. That was achieved long ago. And then learning new skills. That becomes the next one. And innovation is really the characteristic of the current wave of the revolution. Okay? And then there are people who consider that artificial intelligence will take over. All of us, we think we are smart people, but artificial intelligence will be so good that we will be out of business ourselves. And as a scale, you can think of the first part as evolution, when you went into learning. Into innovation, that is the revolution. And people will argue that artificial intelligence taking over is hype, but not so fast because there are some very important people who are actually afraid of that happening. Here are two examples. Okay, these are very serious people. Okay, and this is the exact code. These are words out of their mouth about artificial intelligence. So they think it may be the end of the human race, according to the late Stephen Hawking. And Elon Musk, who is also a heavyweight, think that it's our biggest existential threat. I happen to respectfully disagree. I think that if you think of artificial intelligence as a tool, we can always control it. The fear is that someone malicious uses it. That is always the case whenever you have a technology. Nuclear technology is there, and obviously if it falls into the wrong hand, we have a problem. If artificial intelligence is used maliciously, it is obviously dangerous. But for it to take over on its own, in spite of our better judgment, I don't think this is a realistic fear. That is my own assessment. So I would go and develop it and make sure that there are safeguards that it's not improperly used. But on its own, I don't think it will be our enemy anytime soon. Okay. Now, I'd like to emphasize again that the main idea is learning. When you talk about intelligence or the other manifestations of this field, learning is the key buzzword. This picture may mean something to many of you. IBM had a sort of a lull in its perception as a technology powerhouse some time ago. So they went and did 2 projects that were very, very intelligent and very, very, very smart for them to do. One of them was Deep Blue, was the first computer program to beat a world champion in chess. And then they did this, which is basically a combination of natural language processing and very efficient search in order to play the game of Jeopardy and beat the world champions in the game. And actually, they won very well. So everybody who's watching this thinks, oh, this is extremely intelligent. But we have to realize that this is a system that does one task. Okay, it plays Jeopardy. Okay, and if you go to something else, it may not be that good. In the US and probably in other parts of the world, we will call this one-trick pony. Okay? So it does that, you take it to another field, it doesn't. And it's very important to realize that if you want to have intelligence, you have to have a system that can adapt to a new situation on its own. It has to be able to learn. And for example, if you take the contrast between AlphaGo and AlphaZero, that was exactly the step that was taken to make sure that we have something that adapts to a new situation rather than something being designed for a particular game, which is the game of Go. Okay, so learning is the key, and let's follow the history of how it happened. So if you think of the current development, the way I would put it is this. Recently, there has been a great revolution, okay? But if you go back even 40 years or longer, there has always been progress in machine learning, usually for what I call low-hanging fruit. You go for a company, Amazon wants to sell books, and someone chooses a book, they want to recommend other books that are similar. Very straightforward to do. You can obviously become more sophisticated to do it better, but it's very straightforward. Financial companies want to forecast the market. Credit card companies want to approve applicants. There are lots of possibilities where there is data, and all you need to do is just have a disciplined machine learning approach in order to get a result that beats what the current performance is. This has been going on, and I sort of liken it, if you think of tools, this is like the regular screwdriver. It helps human beings do a job, okay? Some value added. And then all of a sudden, we are now very ambitious. It's no longer low-hanging fruit. We are extremely ambitious. We want to beat human intelligence. We want to achieve things that have not been achieved before. We want to have, all of a sudden, this is possible, okay? So now we have the more interesting, this thing, the more elaborate screwdriver where you can really achieve, higher things. And it took actually quite a road in order to arrive there. This is not something that happened overnight. And I'd like to give you the ups and downs of that road in order to appreciate where we are in terms of what it took to get there. So you can look at the ups and downs, and you start in the 1950s. The first ideas of machine learning and artificial intelligence came about, and there was the Perceptron, and everybody said Perceptron will solve the problems of the world. And this was, in terms of the hype to achievement ratio, this was the highest of all of them, okay? People said that they will do stuff that they weren't even close to doing, and the substance that they had was very little. And although there was lots of excitement because it was a novel idea at the time, what happened is that people didn't deliver, and by the 1970s, AI became a bad word. That is, you don't say artificial intelligence in good company, okay? People will think that you are just hyping, it means nothing, and whatnot. And it is at the end of that era that I joined Caltech and started my scientific career, which is the 1980s. And when we had similar ideas to achieve machine learning or to achieve artificial intelligence, nobody in their right mind would call them artificial intelligence. Okay? So it was very happy to find a model which has a biological inspiration, which was called neural networks, and that was the focus in the 1980s, and a similar level of hype happened. Neural networks will solve the problems of the world, will do all of the above, and they are the great future at the point. Now, neural networks did not deliver at the time, but they were not as dismal a failure as the previous round of artificial intelligence. So they did certain successes, okay? And many of the successes were actually not publishable for reasons that I will become clear, that I will explain in a moment. But in some sense, that wave also resulted in a disappointment, but was a milder disappointment. So in the 1990s, people said, okay, neural networks are not that good. Okay, they may be the second best in doing this. They can do spotted stuff, but it's not that big a deal. And people went on to other models that I will also allude to later on. Okay, and time goes by, and 2010s neural networks are great after all. Okay, so it's an interesting dynamic where it's the same model, same algorithm, backprop. Okay? Same thing, except that you applied more muscle to it, and all of a sudden, you are great. The reason for that is very simple. If this is the level you want to achieve, let's say this is human intelligence, and this is the level you actually achieve, people look at you, okay, nice try, keep up the good work, interesting, maybe in the future. You are not impressing people. You do this, you are still not impressing people. You do this, and all of a sudden you are God's gift to humanity. It's a huge, big deal. And that's what happened, and it didn't happen that, okay, actually it went from this to this. So there is actually something interesting that happened. But from now on, it's a game changer, because things for which you needed humans, you can now replace with machines who are more consistent, they don't have bad days, they don't need coffee, and they will do their job better than you do. So all of a sudden, it penetrates to all kinds of industries and fields. So now, because of this, we come to the new conclusion that ML/AI is the great future. Okay, did I see this before? Yeah, but I think this time it's here to stay, because actually things have been achieved. Okay, so let me give examples of then and now, particularly for neural networks, just to appreciate the contrast. So in the 1980s, when the NIPS started in 1987, okay, so it was a new field. The Hopfield model and early neural networks, backprop and whatnot, was in the mid-80s. So this is within a few years of that. The Bell Lab team took this particular set, which is a very famous set to anybody who did computer vision. Okay, the Earnest in its earlier incarnation, and they actually did a pretty good job. Okay, it wasn't like the best performance ever or whatever, but it was beating other methods that are more standard computer vision, and it was used in the post office for recognition in certain cases. So it would be a case where if you recognize the zip code, it's fine, but you can definitely have an error bar, so you can alert and move it to a human to be able to test it if you are not sure. So it was complementary. It wasn't fully automated, but it was complementary. And interestingly enough, the biggest complaint about the MNIST nowadays is that it's too easy. You can't really tell the different methods which is better because anything works. Well, anything works now. At that time, was not anything works. You jump about 25 years and you come to the AlexNet, and this person, the name may not be recognized. He didn't get any awards. Okay? In my opinion, he is the biggest contributor to the current machine learning revolution, by far. First, he went to a very deep neural network, went to a very difficult data set, and also thought of the idea of using advanced computation like GPU in order to do it. Okay? Single-handedly. His advisor, who is Jeff Hinton, a very famous guy, okay, wasn't sure that this is a good idea. But he did it, and then he beat the state-of-the-art for ImageNet, which was the standard data set today, by a huge margin, and that changed people's mind completely about what can be achieved. From that point on, people were using it, and computer vision now is completely deep learning as a field, and many other fields tried to open it. So he did the proof of concept that you can do something great, and he did it in this case with categorical images, and was able to achieve 16%, which was like unbelievable for that time. It was 20-some% before, and once he did that, people started, okay, we can do it. You use 10 layers, I'm going to use 100 layers. You used, 4 hours of GPU, I'm going to use 2 days of GPU. Just people went nuts at it, and now it's down to 3%. It beats human performance. So the minute you know that you can do it, all of a sudden, everything, the gates open for the prospects. Another one, which will be familiar to the organizers of this particular summer school, is game playing. So I don't know whether you even know about the TD Gammon, which was actually one of the most successful published results in neural networks. So it was done in 1992. Backgammon is a simpler game, and Jerry did a great job. He did it basically single-handedly. He was at IBM, but he did it single-handedly, and he came up with a system that learned backgammon by playing against itself, so it established the concept. So there are no expert examples. So it's AlphaZero version rather than AlphaGo version. And he actually got a system that was the best automated system and actually started beating human experts. It wasn't the best player in the world, okay? So again, it's one of those things. You are very close, but once you beat the best player in the world, everybody will listen to you. So it wasn't given as much attention. It was a great success story. And given the resources they have, if you go back and ask yourself what is the amount of computation available and whatnot, even for IBM, it's nothing comparable to this. I mean, people take it for granted. I joined Caltech as a professor in the early 80s. At that point, the disk capacity of the computer system in the CS department was 3 gig. I kid you not. Okay? So it's just completely unimaginable what the progress is. And now we go to AlphaZero. I mean, in my opinion, the AlphaGo and AlphaZero is what made the wave. Okay? So Alex did the proof for computer vision, but this one people could relate to, and especially AlphaZero. I'm very partial to it, obviously, because it's really a pure learning system, and you can learn many games, and in 4 hours you can beat the wave. It's just unbelievable achievement that everybody can relate to, and it is what resonated with a lot of people. Okay, so let me go through the successes that happened before in order also to put the current success in perspective. The first success in neural networks, which happened in the 90s, happened to be in the financial applications, both in financial forecasting and in credit card approval, in consumer, and sometimes in also the consumer or corporate credit. And one of the biggest problems is that almost all of it was never published. Financial companies don't publish the results. I mean, we have the saying that if I get a good result, you will hear about it. If I get a great result, you will not hear about it. Okay? Because obviously you want to use it for other purposes. So there are lots of companies that have lots of internal machine learning and neural networks in particular applications that were not published during this period. I suspect that you never heard of this. That was the biggest early success. It was never published, but it made many people very, very, very wealthy. So when the neural network started, there was a young man at the time, Robert Heck Nielsen. He came to the meeting, which was prequel to NIPS at the time. He was working at Hughes, and he was very excited about this and decided to start a company. And he called it Heck Nielsen Neurocomputers. Okay, and everybody was skeptical because he basically it's almost like he wants to replace your PC with a neural-based something. Okay, so he started it, and the idea was novel. And people started funding it, and it made the press. You can see the date of it, it's 1987. That's 2 months before the first NIPS started. And eventually, you are looking for the killer app, and then finally, he found the killer app in terms of detection of fraud for credit cards. Okay? So that was done with neural networks. And all the companies that use credit cards use this system to detect fraud until this very day. Okay, and his company was acquired by a credit company, and it was a great success that was, again, never published. So this era of the financial applications was great in terms of achievement, but it did not make the headlines, except for when a company starts. And one of the reasons why the financial markets were the first application of machine learning, because they had the data. Okay, machine learning needs data. At that point, we didn't have data right and left that we have like now, but financial markets keep the data of the markets all over, so it was a great fertile ground for us to apply machine learning, and I got into it, and many people got into it, and it was the earliest success. There are lots of other successes. I'm giving them sort of the big fields. So the second round was e-commerce. And that's also because it was data-driven. When Amazon starts, it starts selling, it has lots of data, and it wants to recommend things to you, okay? And I mean, recommender systems will be discussed. Machine learning was discussed already yesterday, so you have seen that. The other successes like natural language processing were discussed this morning, and recommender systems will be discussed also tomorrow, and reinforcement learning for games will be discussed I think on Saturday. So there is a program that covers all the aspects that I'm talking about in technical detail, so that if something sort of catches your fancy, you can actually learn about it in more detail. So in this case, the idea is just to recommend, and basically you look at people who choose items, and you try to correlate the taste of people with other people and with other items, and you'll be able to recommend something that they will go for. Okay, this is one of the interesting applications that I had. There was a company that approached me about maybe 15 years ago, before this became like an established field. And they wanted me to help them find recommendation, and it was a women's fashion company. So the lady logs in, and the first screen was recommended items that they think that the lady would be interested in. And if they actually make good recommendations, they tend to make lots of money, not only because the lady will buy, but also because the lady will go back and look at the screen, because in her mind, this is meaningful. This is not just random advertisement. This is actually tailored to her. So they wanted to come at me, and they came to me with this, and I'm applying machine learning. I'm the last person who knows anything about women's fashion. I cannot claim any expertise there. And I was competing with professional stylists who would profile the customer and profile the product and try to match them. And all I did was data, okay? Here are the women. Here is what they already ordered. And you run your recommender system, and you come up with a recommendation. And in no time at all, I was able to beat the experts by more than 20% in net sales, which is huge for that time, okay? And they did the A/B test, and everything is fine, okay? And mind you, I still know nothing about women's fashion, okay? I don't know what I'm recommending. I mean, is it a shoe or a dress? I have no idea. It's an item, okay? And that's the beauty of the data. When you are working in machine learning, you can become jack of all trades, because you go to a field and you don't care about all the stuff that they're saying. Give me the data, and you are ready to go. And based on the data, you can. It's data-driven discovery. And also the profiling, which is actually now it's a big deal when you profile people in order to be able to recommend things for them that are interesting. And it is now total profiling, as I will explain in a moment, which is actually more interesting than that. It is an interesting step to understand that this happened finished about 10 years ago. This was the Netflix prize. Some of you may be familiar with it. It's one of the most famous data sets out there, the movie user and recommending movies. And this was quite an event in the history of machine learning. So first they said, if you improve our internal system by 10%, we'll give you $1 million. So the number was attractive enough that people got into it. And when they gave the prize eventually to the guy, the head of Netflix said that, crowdsourcing, which was this idea, I have the problem, I'll give you the data and let everybody work, and whoever gets the result gets the reward. So you just, leave it outside, okay? And that set a number of precedents. First, the guy at the end said, okay, I'm giving $1 million, you think I'm generous? No. He looked at the number of people who worked and the number of hours and whatnot, and he said, I have been, over the past 3 years, I hired PhDs at $1 per hour. When you divide it out. So actually it worked very, very well for them, okay? And that actually was the prequel to Kaggle. I mean, some of you are obviously using that after the finish, the idea is great, and Kaggle started becoming a standard thing in machine learning. So it also gave one lesson that actually was very hurtful at the time, but was here to stay. Machine learning has lots of experts, and they work on it, and they are very sophisticated, and they have mathematical results and whatnot. Almost all the winners in this competition were regular people. Two undergraduates who got interested in it, some psychologists from somewhere. So all of a sudden, we realized that you can actually do very well in machine learning without having the technical sophistication. You can learn it in a hurry, okay? So that established in people's mind that machine learning is art and science. The science is only part of it. And a lot of people who were absolutely the world experts in sparse matrix factorization, which is the main thing here, couldn't compete with the other guys who were basically hacking it. So you realize that actually there is this factor, and that established that. So right now, people are not intimidated. When the new wave happened, every Joe and his cousin, tries to work something in machine learning, okay? And that actually was very useful to the field, as I'm going to describe. In the current wave, which is very important, it's really the perception tasks that took off big time, and obviously the game playing. But this actually was very important because it drew a lot of press attention. When you can start, the machine can see or can talk to you and whatnot, this everybody can relate to, and the press becomes interested. And that gave huge publicity to the success of machine learning to the level where everyone wants to take part of it. So there were lots of interest that came to it because of this. Okay, and that has, speech recognition and object detection and machine translation, natural language processing. These are things that are also covered here. Okay, and it took the revival of neural networks with more layers this time, and that gets us to the idea of what is the sort of the models. So if you look historically at the models, you would see there is a comeback of neural network. 1980s, neural networks were the thing. And backpropagation was there, an efficient algorithm. And backpropagation did to neural networks what FFT did to signal processing. It's an efficient algorithm, and then you can apply it everywhere, and there are lots of advancement because of that single algorithm. And that's what happened in the 1980s. In the 1990s, because neural networks did not deliver, people looked at other things, and a great model which is support vector machines came up, and it was the model of choice in the 1990s. And then in the early 2000s, boosting algorithms came, and some of them are, you are using, some XG boost or some other models now. And the idea was to put together weak learners in a bigger system that performs well. And even computer vision started working with the boosting algorithm instead of the traditional methods. And then in 2010, neural network made a comeback, the comeback of the century, I would say, that in huge deal to the level where now people are not looking even at alternatives. And the only thing is that you have a bigger network, you can afford to do it now, as we will see when we discuss the ingredients of the current revolution. Okay, so that's the history. Let's look at the essence of machine learning. Okay, I'm trying to abstract it in order to see what it is about, and then look at what ramifications are. Okay. So if you look at the different fields that I mentioned with the buzzwords, they have something in common, which is the automated detection of a pattern based on the data, okay? You are not to interfere with the data in building your system, okay? You think you are smart, I think I'm smart, but this is data-driven. And for example, in science, data-driven discovery, you look at the data and you try to find a pattern without applying the prejudice of human beings, whether that prejudice is helpful or not. That is, yet to be found, and it has been found that our wisdom is not that appreciated in many systems. If you take it out, the system performs better, and there is a reason for it, and I will discuss that. Okay, so this is the essence. If you have data and you are learning from the data, hence the name of the course that I gave, that is what machine learning is about. So my standard example for that, it should be very familiar and easy for you. You are doing credit approval. Someone applies. You want to say whether you approve credit or not. And what you do, you go back to historical records of people, and you see that how they looked when they applied and how they actually eventually performed in terms of credit. You try to find a correlation, a nonlinear correlation, hopefully, between the data at the time of application and the prediction of their credit behavior. And when you find that pattern, you apply it to future customers and approve or not approve. Very standard. But that also gives us the main difference between human and machine when they do that. When humans do that, you have the credit score. So they give different weights to different factors. If you make more money, that's important. If you are in big debt, that's bad. If you have been in residence for a long time, that's good because you are stable, whatever it is. So they try to give certain weights and end up with a score, credit score. If your credit score is above threshold, they approve it. If it's below threshold, they don't. So it's a linear system. That's how people usually think. Now you start applying machine, and machine is just looking at the data and trying to find a dependency that is consistent with the data set. It doesn't matter what that dependency is. So you start going nonlinear, and you start going highly nonlinear, which is the interesting part. So if you look here, this is a system that probably will tell you that maybe if you make more money, you are less creditworthy in certain regimes. Maybe if you have a certain amount of money that is minimal, you are careful. When you get more money, it gets to your head, and you start spending right and left, and you are in trouble. All possibilities are there. But we are not going to have philosophy about people's behavior here. We have data. These people behaved well. These people didn't behave well. Can you tell me what makes these people behave well? And you look at the data and you find the pattern, and the pattern could be ridiculously nonlinear, okay, and not constrained by our prejudice or our philosophy. And that is the charm of getting an automated system to do. And it is a matter of record. This is one of the earliest successes of machine learning. And pretty much every credit card that is approved using a neural network. Okay. So if you want a characterization of when machine learning should be used, it's a very broad characterization that tells you it can be used basically everywhere. Okay. First, you need a pattern to be there. That is what you are trying to detect. There is a difference between the existence of a pattern and you knowing what the pattern is. We are only asking for the existence. For example, I know that your salary is related to your creditworthiness. I don't know how. There is a pattern that I don't know how, but a pattern exists. That's all I care. When you are rating movies, if you like the movie and someone else liked the movie, then I can say there is a common taste, and there is likelihood that you will like the same movie again, or maybe not. There is a pattern. So the pattern existing is the absolute cornerstone. That is what you are trying to detect. The third part is also absolutely critical. You have to have data representing it. You have to have representative data from which you can detect that pattern. These are absolutely unnegotiable when you do machine learning. The second one, which used to be a standard, is that we cannot pin the pattern mathematically, because the idea is that if there is a pattern and you can pin it down mathematically, just code it and go home. Why do you use machine learning? You know how to do it, okay? It turns out that nowadays, machine learning is so easy and so nice that we might just be lazy. We don't want to do that, okay? So let's just take the data and let the system do it. And there are actually more legitimate cases. For example, I will show you cases where there is a differential equation, so we can pin it down mathematically. But it will take us a long time to solve. Can we just train a neural network to simulate the solution? And we do that. And that's actually one of the applications there. Okay? So these are the prescriptions, and they apply almost everywhere. And now we come to the building blocks. This is where I want your most attention, and this is most relevant to the summer school. I'm going to mention 6 aspects about the model that we are using now that are important and critical in your understanding of them. So the model is neural network. It's deep because there are a number of layers. So you can see that it starts from very primitive inputs, okay? And you go to higher level representations. And this actually reflects, for example, the visual cortex, where we have layers. So in some sense, there is a biological inspiration and existence proof that something like that would work. And hopefully that this also will work. Okay. And this is the building block in everything you have seen. You could be doing natural language processing, you could be computer vision, you could be doing this and that. And this is your building block. Okay? And I started with a generic neural network, dense neural network, if you will. There is nothing about the architecture that makes it, go one way or the other. It's just ready with parameters sitting there ready to learn. So the first thing to notice about it is that it's expressive. Just because you have higher and higher representations, you can capture very complex patterns. Okay? And you can see that this is true because I can now take, first primitive features are not very impressive, but when you get features of features of features of features of features, you can get to the high level, to the level of getting to the cognition level. Now, please understand in machine learning that being expressive in that sense is necessary, but not sufficient. If you are not expressive enough, you are not going to learn regardless of the data you have. You are limited by the model. The model cannot do this, so you can train it forever and ever and ever, and it will never get to this. So you have to have it as being expressive. But being expressive is not sufficient because there are lots of expressive machine learning, extremely expressive models that don't work. For example, if you take a shallow neural network, just 2 layers, and you take the hidden layer to be very huge, you can prove mathematically that this can approximate any function you want, as expressive as you want it to be. If you take the support vector machines and you take the the Gaussian kernel, okay? The Gaussian kernel with support vector machines can implement any function, any binary function. But the problem with those guys is that they overfit. You have many parameters, you try to learn. Since there are so many parameters, the system will memorize your data, will impress you totally. It performs 0 error. It does the training data perfectly. You go out of sample, and you are in horrible situation. You didn't generalize at all. You didn't learn. You just memorized. So what makes a system that has that many parameters learn versus memorize, that remains a mystery, and that's one of the challenges that I'm going to talk about. Okay? So in this case, it's not only expressive, it's expressive without paying the price, as I will talk about. Okay, so that's number 1 out of 6. What is the second one? It's composable. So the idea of backpropagation is that there is an error. The error is actually, the error is at the end. Okay, so the error is here. Okay. Okay, so this word actually belongs here. That's the error you compute at the output, and then it propagates back. Okay. And it propagates back according to the chain rule. Okay. Now, the chain rule is very friendly, because now if I tell you I have a neural network, and I have 2 other neural networks in parallel that I'm going to feed into this neural network, and I have another neural network, I just can have a jungle of these guys. I can compose them without any problem at all, because it's not only that they compose as a functionality, everything composes a functionality. If this does a job, this does a job, I put them in cascade, they will do the composite job. But when you want to learn the function, you need to be able to adjust the parameters of everything optimally at the same time. And this is because it's chain rule, you can do that without worrying that you compose it, because if the error propagates and you modify the weight, and the error propagates further now when you have another one. So that makes you think about all kinds of possibilities, and some of the models you have seen use more elaborate neural networks and perhaps more than one neural network, and you still have the same principle applied. So that's number 2. The other thing is that it's a flexible architecture. It can be easily modified. For example, I take this feed-forward neural network, and I may decide that I'm going to tap some of the guys inside that have some either intermediate feature representation or even the output, and then feed it to the network in the next step. So now there is a time series. I apply an input, I get an output, but I also get something that I'm going to apply the next step. Okay? And by doing that, you get recursive neural networks. Recurrent neural networks. Okay? So when you do this, just that modification and backpropagation still works, and now you can apply it to something like natural language processing where there is a time series. Let's say you are parsing a sentence. Okay? So the fact that it's flexible makes it, and you can see other architectures that we are going to talk about. The other aspect is that although I gave you the most general model, you can specialize it. Okay, so for example, you can say, okay, with the vision, I don't really need a full connection. When I look at an image, I'm looking really at, my visual field is focusing on different parts. The chances are I'm taking different parts the same way because, whether you are here or here, I still recognize you as the same person. So you come up with the idea that came in the 1980s, which is, in this case, convolution neural network, which is still a feed-forward neural network. And then, but you can have different aspects. You are partially connected to this. You have the same weight. You are sharing the weights. You can modify this in different ways. And for example, when you're doing natural language processing, okay, you are going to use recurrent neural networks. But then after that, you decide, okay, if I'm very much focusing on this, I need something else. And then you come up with the long short-term memory, very specified with gating and whatnot. So there is a lot of flexibility in modifying the architecture in order to suit different applications. And similarly, I think there will be talk about generative models probably on Friday, according to the program, which is one of the most interesting ones. It's something called GAN, which is two networks competing against each other, fighting each other, and this way you can generate data that look like something that look very authentic while they are actually completely artificial. And the embedding, like embedding of words, you have languages and you want to represent them as a vector. And so every idea imaginable, you can simply use that one. And the fact that there is this flexibility made people have a great appetite for improvising ideas. So there is a crowdsourcing for the research in machine learning. If you are anywhere in the world, you come up with an idea, you can try it. But that also raises a philosophical question because we are supposedly learning. And now I'm going into the network and making it do something because I think this is suitable for this problem. Okay? Alarm bells, because what I think doesn't matter, right? We agreed on that. Supposedly the data will speak. Okay? And that actually gives us an interesting contrast comparing to human, which is learning versus evolution. Okay? You think, okay, so we are very good at learning, so I can learn this, I can learn that. But part of the learning was much, much longer term, okay? Probably the first species didn't learn very much, and it evolved over time. It started getting a specialized architecture to deal with the typical problems that you are facing, and now we are more easily able to learn. So there is a basic learning to get the right architecture, and then fine-tuning, as you know, relatively speaking, which is the actual learning we are doing. So think of the other guys as if they were the evolution. We are getting the systems that is suitable. Okay? I'm still partial to the dense neural networks, blank, all bets are off. You let the system figure it out on itself. Okay? And actually, in the alpha series, when your AlphaGo, we started, tweaking things and using experts and whatnot, and then you made a leap. Let the system learn just based on the data, but you may still, tweak the architecture. And at some point, you will get the system where you don't even have to tweak the architecture, because our lesson, our biggest lesson, which is a big blow to our ego, is that we are not that smart. We are very smart, but our goal is here, so we are not smart enough to be able to interfere with what this guy is doing. So just get out of the way is the key. Okay, and that leads us to later on. Okay, so this one again, the fifth aspect of the neural network is actually also pretty interesting. It opens the doors for reinforcement learning and for other applications as well. So the idea in general is that I have an input, I have a target, I want the network to predict the target based on the input. Now, in the course of doing that, I decided the way I'm going to do it is by defining an error function, which is the difference between what the network does and what the network should do, which is the target. Compare them, define an error function, and this is the one I'm trying to minimize. That's universal. A byproduct of that is that I don't really need the target. I just need the error in order to carry this. So if I can define an error without even knowing the target, I can still use this. And that's a biggie, because there are many cases where I don't know the target. You play a game, you don't know whether it's a good move or not. But if you do it and you keep going on, you lost or you won. Okay? So you can define the penalty for that based on that. Okay? The example that I gave you, which is solving differential equations. Let's say I have a square, and I want to know the temperature distribution inside. And as a boundary condition, I'm going to give you the temperature distribution on the frame. There is a very simple differential equation. You solve it, and you get it. Okay? And the differential equation tells you that certain combination of higher derivatives should be 0 at every point. And then you put the boundary conditions, and you have the full solution. So people now do what? They use a neural network. So they input the boundary conditions only, and let the neural network fill it in. And how do they know that there's a good solution or not? They apply the differential equation at every point, and if it is different from 0, that's your error. So they backpropagate in order to make it 0. Lo and behold, eventually you actually get the solution. And now you have something that maps the boundary into the solution directly. So this opened a whole world of possibilities. Finally, that is the biggest item of deep neural networks that I'd like to draw your attention to, which is the following. You typically, if you are using statistics or even the classical machine learning, you realize that I need more data than the parameters. And there are all kinds of conventional wisdoms, like 10 times as much data as the parameters, in order to generalize well. What is the idea? So the parameters are the knobs in the system that you can tweak one way or the other in order to make the system implement one function or another. If I have 100 knobs, and I have only 3 data points for this input, get this output, this input, this output, this input, this output. It's not that difficult to find a setting of the knob that actually does this mapping. As a matter of fact, the chances are I'll find more than one setting that does this mapping. But in the course of doing that, what I'm doing, I'm just memorizing the 3 examples that you gave me. I'm not learning anything. I would claim that I learned if the 3 become 3,000, and I still have my 100 knobs. So now I don't have enough capacity to memorize, so I must figure out what the underlying pattern is, or I'm not going to be able to fit the data. So if I manage to fit the data, and there are that many data points, and I don't have many parameters, I have a theoretical guarantee that I will generalize, and generalize is what we care about in machine learning, period. I have no interest in the training set other than giving me the road to find the underlying function for the test set, for data that I have not seen before. Memorizing the training data has no value to me. So all of a sudden, you go for this, and you have maybe tens of thousands of examples, and you have hundreds of millions of parameters, the weights of the network, and you still generalize well. That is a great break, and it's very simple to understand that if this break didn't happen, there will be absolutely nothing to talk about. We wouldn't be having this summer school. We are having this summer school because by divine intervention, we were spared from the fact that we have far fewer data than the parameters we want to use, because we went crazy with the parameters. Deep neural networks, 100 layers, this and that. Oh, I have 200 million, and I have 50,000 examples. You still learn, and you still generalize. How this is happening is not understood, and it's obviously a lot of people are curious about it, including myself. I have an ongoing project, and I'm going to talk about it a little bit in the closing part. Okay? So these are the 6 things I wanted to communicate, and you now have a model that is great, it's lucky, it's flexible, it can apply without knowing the target, and now you can use it in almost any idea that comes to mind, which is what has been happening. Okay, is it the depths or the widths? That's a question to be asked. Okay, now let me tell you about the ingredients of the current revolution that made this happen. Okay, I think I'm okay, because okay, so now I'm just telling you what made this happen. What is the difference between what is happening now and what happened 10 years ago? Okay. First ingredient is that we don't interfere with the learning. Used to be that when you want to do computer vision, first step is to help the poor machine by making its task simpler. So instead of giving it the raw image, pixel by pixel, which is nonsense, I'm going to go and extract edges and do some funny stuff, higher level features that are relevant to the content, and then I'm going to feed these features to the learning process and let it learn. Okay? We learned the hard way, no pun intended, the hard way that this is bad. Because the way the machine may be reading the image is completely different from our understanding of it, and is superior to it. So in this case, you let the machine deal with the most primitive features possible, pixel by pixel. Okay? You have 3 colors. These are 3 inputs. No summary whatsoever. Let it figure it out on its own. And as a result of that, the first few layers of the network are effectively extracting features. And these are internal features that the network found out. But the point is that they are extracting these features with a view to the task at hand. They are optimal for that task, and for that particular architecture, and for that particular data set. Things that we are not able to comprehend because it's a practical thing, highly nonlinear, we have no idea what it is. But think of that, whenever you automate something, there are advantages over humans. As I mentioned, the consistency, the volume, you don't forget. You can structure things that beat the humans. Okay? Now you add to that the machine will figure out the features that are more relevant, and basically we don't have a chance. Because even the features, I look at the image and ask you, is there a boat here? And you have some understanding of it. And all of a sudden you find a feature which takes this pixel and that pixel, and what is this? Well, it's relevant to being a boat, but not very explicable. And the fact we are doing this, the machine is trying to do the task well. It's not trying to make us understand how it is doing it. It's just doing it. Okay? And in the course of that, you get a dividend of performance that humans simply cannot compete in. From that point on, you are already there. Okay? And I don't know how much room there is after that. So that's the first factor. The second factor is the jump in computation. There used to be Moore's law. You may have heard about it. It's basically no longer operant, which is the fact that every 18 months, the computation power doubles. That law stood very strong for the longest time. Okay? It saturated about 10 years ago. So it used to be that when I give up on my old machine, which is 3-4 years old, and buy the new machine, I'm already maybe 4 times or 5 times faster than it used to be. From a point on, it's the boring around 3 gigahertz clock. Nothing happened. I have more cores, etc., but you got saturation. So all of a sudden, and that's actually due to Alex, of the AlexNet, you realize, okay, the operations I'm doing in neural network can be done very quickly using things that were developed for other applications, in this case, computer graphics. And all of a sudden, you have 2 orders of magnitude speed up. Okay, all of a sudden. It's not like you didn't have to wait for 2 times 2 times 2. It's all of a sudden. Okay. Now, you may think, okay, I mean, computation is great, and obviously this is a GPU, there is a TPU, there are all kinds of ways to do this very fast. But this actually has an impact on a field like no other. It's not like we are in a hurry. It's not like we want the thing to finish in 3 seconds versus, whatever, 300 seconds. That's not the issue. The issue is that if you have an idea that really takes a lot of time, okay, in this regime, you can run the job Friday afternoon, enjoy your weekend, Monday morning, the result is there. If you didn't have that, that would take a year. No one will explore an idea for which they have to wait a year. But if you give me that ability, I am going to explore every crazy idea under the sun, even as crazy as dropout. Have you heard of dropout? If you tell me what dropout is about, I'll tell you to get out of the room because you are wasting my time. That was the impression of everybody. Even the person who invented it wasn't trying to find regularization. Was trying to cut the computation. Let's not update everything every time. Let's update some of them. And all of a sudden, there is a great thing, okay? And all kinds of activities you got. If you find that you look at batch normalization, all kinds of ideas. There is a huge army of people with ideas that they can actually try, and the ones that get published, and we adopt them, okay? That would have been out of the question without this speed. So it's qualitative, it's not just quantitative. That's number 2. Number 3 is the elaborate data sources. So obviously, I told you that financial markets were great because they were that's available data. After that, we get the e-commerce. Now we have so much data that people start becoming very ambitious. For example, the total profiling project that I mentioned, I wanted to take this was like 7 or 8 years ago. Wanted to take data from the books you buy, the movies you like, what you say on Twitter and whatnot, and then discover other things. So I can discover, for example, that if you like dark chocolate, I can sell you a vacation on the Caribbean. Okay? So crazy ideas. So I was preparing this talk when I had a meeting with a big retail company in the US just 3 days ago, and they told me a very interesting remark. So they are working on health and wellness, and one of the ideas there is that they want to be able to predict when people have diabetes. Diabetes is very prevalent. The majority of people who have diabetes don't know that they have because they don't run the test until it's too late, which is a disaster. Okay? So they are looking at the data, and because it's huge retail, they have a health unit, and they also have the retail unit. So someone discovered, yet to be verified, but it's an interesting concept to realize, is that so they have your shopping habits. So it's not like you go for the obvious. If you buy lots of chocolate, you might have diabetes or whatever. Okay? No. They actually discovered that if you change your detergent brand, you are likely to have diabetes. There is a logic to it. It's not that random. When people have the pre-diabetic stuff, their skin starts breaking. They dismiss it as something that is maybe they're using the wrong cream or maybe the wrong detergent. So they switch. So if you have been using Tide, Tide, and all of a sudden you become far more likely that you actually have diabetes. Of course, I'm not saying that this is the prescription, but it opens your mind. If I have data on the person, everything they buy, everything they like, etc., and I have data on millions of people, I will be able to detect patterns that are completely unthinkable. And that is the strength of having these data sets. Finally, this is one, and it's very relevant, particularly to this region, which is the fact that effectively research in machine learning has become a crowdsourcing thing. Okay. If you want to work in nanotechnology, good luck. You need a very expensive lab, and I can see the bureaucracy and the priorities and this and that. What do you need in order to start in machine learning in earnest? And in 6 months, if you are smart enough, become a genuine contributor. Have your name recognized by everybody. have a method called after you. Solve an unopened problem. I'll tell you what you need. You need a laptop. I'm not joking. That's what you do. Thanks to the wonderful players who did TensorFlow for free. They optimize the heck out of everything. This is like a nightmare. If you do this from scratch, it's a nightmare. Okay? And again, you want something very efficient in order to be able to explore ideas. Okay? You want code? Just go to GitHub. You'll find 100 people wrote similar code, and you find something like Keras, for example, which is everybody's using nowadays and everybody's adding to. Okay? Okay, so we have the software. How about the hardware? They are giving it out for free. I mean, it's really a bonanza. I have no idea how this is happening. But you go to, there's Google Colab. If you go to the Amazon Web Services, if you're a student, they will give you this. You can run on the fastest machines any ideas you want for free, okay? No excuse. No barrier to entry. It's on you, okay? The ideas are clear. The models are there. The facilities are there. It's on you, okay? And as in terms of the barrier to entry, the expression in business, the barrier to entry here is 0, okay? And for something that researchers are here, there is no shortage of smart people in this part of the world. Trust me. I met so many of them that impressed the heck out of me. The most intelligent person I have ever met was an Egyptian student who never made it to anything, okay? And I met maybe 20 Nobel laureates so far. I knew some of them closely, and this person remains the most intelligent person I have ever met. Just didn't develop the talent enough. And I am extremely passionate, as I will probably talk about it in the panel, about the development of individual talents. I'm not interested in organizations. I want people who are talented to fulfill their talent. If you do that, and that alone, everything will be fine. There will be great stuff coming right and left. And we are in a place where there is a great resource for that. Okay? That's my pitch for that. Okay. And finally, just to mention this, obviously that, it's not only that you beat the best, but also you find strategies that nobody thought of. This was the most impressive example. T.D. Gammon had an example of that, but it wasn't that impressive. It was almost like concocted in order to make the point. This one is absolutely, because the game of Go has been played forever. And the interesting aspect, if you get the performance, so this is the human performance of the experts, and now you are here, okay? I'm extremely curious if you can get here. I mean, if you can get something that is really, really superhuman. I mean, we are intelligent, okay? And we are proud of that. And you can see that on the scale of intelligence, it's highly nonlinear, okay? Monkeys are smart, but there is no civilization. You go from monkeys to humans, man, that's a change, right? So the level of intelligence that makes you achieve is rather interesting. That you cross a threshold and there is a phase transition like there is no tomorrow. I'm extremely curious about, okay, I mean, we are here and we are smart. Is there something a little bit deeper? I mean, beating us, okay, I mean, beating us can be, if you are beating by a small amount, you say, okay, the guy lost his concentration, he didn't sleep well, okay, a machine is good. But if that, then you absolutely positively know that there is something qualitatively different, and I'm very curious about that. Okay. Final part of the talk very quickly. Okay, so I mean, this is upcoming, the self-driving cars. Let me skip that. Okay, the challenges, okay? Okay, I'm going to talk about 3 categories of challenges, which I find very important. The first one is what I talked about the generalization, okay? How come you generalize well while the number of parameters is over-parameterization, like on galore, okay? And there is a project I am doing with Professor Dimitri Psaltis in EPFL in Switzerland, which actually has a very good chance of pinning it down, because we have taken the case of something standard as MNIST, and then you get speckle patterns based on it, and you try to recognize the label not based on the digits itself, but based on the speckle pattern, which is an image. I mean, it's not an image that we would understand, but it's an image. And we realized that in spite of the fact that you learn perfectly in sample, that there is no difficulty for the network to figure out the pattern on the 60,000 examples based on this. It will tell you exactly what happened. The speckle one generalizes poorly, while the other one doesn't. So now we have at least pinned down 2 problems that we can dial up and dial down in order to understand what this is. And my experience, when you take deep neural networks and you go to something like financial markets, it's even worse. Okay? So it's not a question that deep neural networks work, period. They work in perception tasks. That's not a surprise because this is the guy that does perception and it is structured this way. It does other stuff, but it doesn't do everything. Answering the question, what does it do well and what it doesn't, and what is it about the things that it does well that makes it do well, is very important because that is the way we will go to other models and other fields. Okay? So this is the first challenge. It's a technical challenge. By far the most important. There are practical challenges, which is as AI becomes the standard, everybody will be using it. Okay? So there are questions like, bias. Let's say the neural network decided to favor men over women, or women over men, or some race over the other. Okay? I mean, it's looking at the data and figuring out what it is. Okay? And we have a social duty to make sure that this doesn't happen, especially because people will get the system, they will delegate to it, and they will not look at it from a point on. So whatever happens, happens. Okay? It's pretty much like it used to be that you talk to intelligent people on the phone in service. Now they tell you, oh, the computer is refusing. That's it. They have no idea what's going on. So if this has built-in bias, we have a problem, and that should be tackled definitely. Okay? And there are approaches to do that. Also, interpretability. I am of two minds about interpretability. The fact that it's a black box doesn't bother me, but it bothers many people. If you are in Wall Street and you tell them I have this great strategy, they ask you what does it do, because they're going to invest their money in it, and so on. Okay? And obviously, there is an effort with Google, and let me mention the last one, which is an important one, and I will finish here, which is there are some security risks and hacking and whatnot, but the most important part are the social risks. Things are happening fast. People will become unemployed within years of acquiring the skill. That has a serious social ramification. That's one. The other thing is that if you think your iPhone is your best friend now, wait until it's full-fledged AI. It will become your only friend, okay? Because other people don't look as interesting or as nice to you as your phone, okay? That's not good, okay? So these things need to be taken into consideration, and taken into consideration now, because things are happening fast, okay? I went over time, so I'm not going to go to the conclusion. I will leave it there. Thank you.
Thank you very much for the very inspiring talk. So since we're running behind schedule, we won't have any questions now, but please feel free to ask Professor Yasser during the panel session. Thank you.
So we'll have now a break outside, and then please come back at 3:30 to start the panel.
3:40 is more reasonable, like 20 minutes. Because like it's 3:40, yeah.
3:40.
So I think from beginning to end, I went 7 minutes over time.
So welcome to the panel, AI in North Africa, where do we stand and where to go? I'm Hussein. I'm a research scientist at DeepMind, and this is Saad Benjeloun, professor in UMC-SPE, and we will be moderating the panel today. So before we get into the discussion, I'd like to just present the scope of this panel and what we'll be discussing. So does this work? Okay. So we all know that in the recent years we've seen an exponential growth in the interest that people have in AI. So this is witnessed by the fact that the number of participation in landmark conferences such as NeurIPS has increased exponentially in the last few years. Like, for example, you get a 10 times improvement from 2010 to 2018, which is really something unprecedented. This is not something only that is specific to academia. This is also something that we see in the entrepreneurial world, in companies, where we see that the number of startups that are being founded is also increasing very, very quickly in AI. So if you actually compare the number of startups in AI to the number of total startups, the number of startups in AI actually increases much quickly than, much more quicker than the number of startups globally, which is really something indicative that most of the innovation in the recent years is somehow related to AI. So I guess the next question is, where does this actually activity that we're seeing takes place? So this map here shows the number of people that are involved somehow in AI. So basically the number of people that published in a top AI conference or have a LinkedIn profile that is related to AI in some way. And what we see is that the major activity in AI resides in North America, Europe, somehow Asia, but North Africa remains like the activity really needs to improve. And this is really the goal of Nassma, to promote AI in North Africa. So Nassma is really this, we're trying to create this ecosystem of AI that will really promote AI in the region. So Nassma in Arabic means light breeze, and this is really what we'd like to have, like a light breeze on this region, which will increase the activity of AI in the next few years. So, at this stage, we really want to understand like what did the other countries do in order to promote AI, so that we can basically get more data. Here are some examples of AI investments worldwide. So France, for example, is spending around $2 billion on AI. With the AI for Humanity project. This was announced by President Macron probably a year ago or so. And the goal of this national AI initiative is basically to fund the National AI Center, to fund faculties, PhDs, master students, create a funding for startups, as well as create ways to collect more data and create more data. So this is not something specific to France. We also see this in the UK, for example, which is also spending a large amount of money to create, for example, Alan Turing Institute, which is extremely well known. So there is like, in addition to this, there are university-specific initiatives that take place, specifically in the US, for example, where we are recently seen, for example, that MIT is spending a very large amount of money, invests $1 billion basically to create a center for computing related to AI. And Stanford is also creating an institute for human-centered artificial intelligence, whose goal is to basically guide artificial intelligence to benefit humanity. So now these are just examples of AI investments worldwide, and what we'll be discussing here is how to basically promote AI in North Africa. So the questions will be addressing are, for example, as follows. So what are the current efforts to promote AI in Morocco and Africa? How can we retain AI talent in Morocco and more globally North Africa? So obviously we know like the strategies of other countries. How can we benefit from other countries' experience in creating a data science center? And given the specific needs that we have in North Africa, what is a good recipe in order to create a successful AI course? We'll also talk about the entrepreneurial AI ecosystem. How can we build a healthy one in North Africa? So we'll start with questions that we'll be addressing to our panelists. But at a later stage, we'll be taking questions from the public, so please do feel free to ask questions. And we also have a hashtag Nassma 2019. If you would like to ask questions on Twitter, please do not hesitate, and we'll be monitoring Twitter during the panel. So without further ado, I will give the speech to Saad, who will introduce the speakers.
Thank you, Hussein. So yeah, actually to answer these interesting questions, we have a lineup of very prestigious panelists. So we have Professor Yasser Abu Mustafa, to whom we already listened earlier. So Professor Yasser Abu Mustafa is a professor at Caltech University. So he's one of the authors of the bestsellers in the field and the author of one of the MOOC which is most followed in the field of machine learning and artificial intelligence. We have Olivier Verscher, who is the head of Swiss Data Science Center, which is one of the successful experiences in Europe as a research center in machine learning. We have Kamel Mujahid, who is Director of Product Management at Google TensorFlow. So as you saw in Professor Yasser's presentation, TensorFlow is one of the very popular tools that data scientists use. And Google is obviously a very active actor in the field. And we have also from OCP Walid Daou. So Walid Daou is the AI lead at the digital office at OCP. So we'll start by asking you, Walid. So OCP is mining company, a chemical and fertilizer group. And we know as here at U6P that OCP is really interested in AI. So my question to you is why OCP is interested in AI?
Yeah, does it work? Yeah. So yeah, thank you for your question. Well, actually, OCP is the biggest company in Morocco, so it was quite natural for us to be interested in AI, what is AI, and what we can do with AI, given the fact that it's a disruptive technology. And the other thing to take into account is that OCP is an engineering company, basically, it's a mining company, and it has a really strong engineering culture. So we have hundreds of engineers who graduated from all over the world. And the other stuff is that our interest in AI is a part of our global interest in research and innovation. So as you all probably know, we invest a lot in education, in university. We invest in UM6P and other universities. So basically, it was something natural for us to deep dive what is AI, what we can do with AI in our business, and even in businesses where we are not really active yet.
So what is the current strategy regarding AI for OCP? What is the long vision term, and particularly what area of AI is relevant to OCP?
Well, basically our strategy focuses on two areas. You have the businesses where we are currently active. So OCP is a mining company. For people who don't necessarily know, we extract phosphate rock and we sell phosphate rock and its derivatives, so acid and fertilizers. And so AI can improve this part of the business, especially in the industrial part, eventually to improve the process. And also to understand more deeply the market dynamics. So how the supply and demand interact each other. And so we are working on projects where we try to use machine learning algorithms to better understand this part of our business. And of course, we are also looking at how AI can eventually create new business opportunities. So the opportunity that we currently see, or where we think there is a potential, is agriculture. So we try to be closer to the farmer because we sell fertilizers, so we sell fertilizer to farmers actually, and we try to help the farmer to understand more deeply the way his business works, and the idea is to eventually to use all the data that we can collect on the fields of the farmer and to try to interpret using machine learning algorithms what's going on his field and which type of fertilizer he should use. Because eventually, I didn't know before I was at OCP, but you need to know that for a farmer, it's not straightforward at all to understand which fertilizer he should use for this specific crop or for this specific field. And so you have a lot of research to try to say, okay, given a specific farmer, what type of fertilizer he should use. And the other part is to analyze satellite images. So we're thinking about, okay, given all of the images you have, the satellite images you have of different fields of different crops, what kind of information you can really find in them, and how can you use this information to eventually evaluate the health of the plants or other information. So basically you have our current business, potential business opportunities, and to do so, of course, you need people. So we really try to build close ties with universities, of course, UM6P, and even the universities from all over the world. And we train our people, and we hire, of course, data scientists, and we try to collaborate with all the ecosystem.
Thank you.
Okay, so my next question goes to Olivier Verscheur. So Olivier, you've created a very successful data science center, nationwide data science center in Switzerland. Can you tell us a bit more about it and what are the reasons why there was a need basically to create a nationwide data science center in Switzerland?
Sure, thank you, Hussein. And first of all, I would like to thank the organizers for inviting me. This is a fantastic initiative. It's really hitting a chord with me. And I'm very humbled by being part of it, being part of this first edition. So thank you very much. Now to your question, there is a short and a very long answer. I guess I will start with the short answer and you tell me if you want more, basically. So the Swiss Data Science Center is a joint initiative between EPFL in Lausanne and ETH in Zurich. There was a decision at some point that also Switzerland should play a key role in AI and data science and bring some of the data economy back to Switzerland to a certain extent. And so they decided to join forces, those two schools, which never happens. They decided to join forces and create or found an institute, a national institute for data science and AI. I'm the director of that institute. We started back in 2017, so January 2017 was the official launch. It's relatively recent. The mission of the center was very clearly stated, even though it's kind of a blank page, right? You get there, you're employee number one, and you're like, okay, what the heck am I going to do with this blank page? Because the mission was find a way to accelerate the adoption of machine learning methods in academia and the industry, all right? And so that was, I thought that was super challenging and super exciting as well. Just a little bit of my background so that, I give you a little bit of context of why I ended up there. So after my PhD at EPFL, but I graduated in '99, so that's, too many years ago. I spent 17 years at IBM Research, most of those years at the T.J. Watson Research Center in New York. And, I got very excited, of course, and I had, a great job at IBM, but I wanted to find the right balance between, impact and research, making sure that I could work on deep stuff, but still trying to make sure that I had an impact beyond papers and publications. And this notion, the mission as stated by the ETH board in Switzerland, which is the main board of the federal schools in Switzerland, got my attention basically. I was like, wow, I mean, this is potentially exactly what I'm looking for. And so what we decided to do, and again, I mean, the long answer would be to go into details of that, but we basically have both an academic team and an industry team that are working. There is quite a bit of synergies between the two. The academic team is working with some of the academic labs in biology and other places. We're, basically building an institute of data science and AI as a service, right? A lot of these labs will not hire a data scientist, or if they do, the data scientist will leave after 10 months because he's not part of a community anymore and he feels lonely, and that's not what he wants to do long term, so he leaves. Machine learning professors want to publish in Europe and other places, and it may not be what actually the biologists are looking for. They want answers to their own domain science. And so they turn to us, and we help them solve some of these problems. And to bootstrap that, by the way, because you need a bootstrapping period to a certain extent to get this to go, some of the funding that we're receiving at the federal level, we're giving it back to the lab, saying, hey, we'll have this call for collaborative data science projects. If you have any great problem in biology and personalized medicine and environmental science, let's talk, and we'll have this call, and if you're accepted, then we'll use some of our data scientists to help you solve some of your problems with your domain experts and domain scientists. This has been working quite well so far. We have also an industry cell And this industry unit has been extremely successful lately, and we're not using any of the public money for that. It's fully cost recovered. And the way we positioned it is very different. We didn't want to look like a consulting company. So what we said was, today, the data scientists that graduate from a master in data science, or sometimes even a PhD in machine learning or data science, very few of them understand what it means to work in the traditional industry. And I don't mean the Google, the Microsoft, the IBM. I mean the Cartier, the Firmenich, those industries that should not miss the turn of digitalization, but they don't know where to start, they don't know how to start, they don't know who to trust, because there is so much hype around AI that, they all get 10 phone calls a day saying, I can solve your problem, right? So they need a neutral entity to turn to. Or they hire their own data scientists. But again, they have the same problem as the labs. They say, the data scientists we hire, they get bored and they leave. And they get bored, they get lonely, because Cartier maybe has 5 data scientists who don't even know each other, so they don't feel part of a community. It takes them 6 months to have data from the IT groups, and they don't know how to communicate with the business units to have impact. And the life expectancy of a data scientist in a traditional industry in Switzerland is less than a year, right? So, and we're targeting very big companies in manufacturing, which is very strong in Switzerland, in the banking sector, and in the pharma business. And they have a really hard time retaining data scientists. So we said, you know what, we won't work as consultants. What we will do is we will hire those new data scientists on your behalf. They will work on your problem, but they will learn, they will keep learning machine learning because there is that synergy with the academic team as well. But they will also learn how to formulate a problem for real impact. They will learn how to communicate with non-experts and so on and so forth. And they will learn whether or not they want to continue their work and their job in a traditional company. And a year or two down the road, we say, you know what, now you should get hired by the traditional company. The Cartier, who might have worked with a certain data scientist for a period of 18 months, maybe like, now I understand the return on investment of that of a data scientist in general and of that particular one that I've worked with for the past 18 months, so I would like to hire him, and we give him back. So it's, again, that's an education platform, if you will. So I'm not sure I went into a slightly, between a short and a long answer, so I don't know exactly whether
so I want a part of the long answer, which is like the relation between the Swiss Data Science Center and the university, basically. So are you also like proposing master's program, for example, or?
So yes, so there are multiple connections. First of all, we benefit, so we have a lot of affiliated labs, right? Whether at EPFL, with the likes of Martin Yagi, there are a lot of professors in machine learning at EPFL, at ETH Zurich, of Andreas Krause, Peter Bullmann, Joachim Buhmann, and so on. So we do have a lot of affiliated labs that can, in some cases, when it's really a deep academic problem, we say, okay, you know what, this is potentially not the role of the Swiss Data Science Center to tackle. We may want to do it in collaboration with a lab, but this is not something we should take on ourselves. So we delegate it to a lab, or we work jointly with a lab on the deeper problem. So this is the first part, is to work hand in hand with people who develop deep methods, that work on foundational data science, if you will. We also have the link with the method, with the application labs, the labs in biology, in medicine, and so on and so forth. And we create those links as well. In terms of education, we have 2 angles. One is, we participate in mastering data science, yes, for both schools. But we also work a lot on continuous education. And so we have actually started a joint program, and I'm one of the academic director of a joint program with HEC Lausanne, which is a business school, of what it means to do, data science and management for leaders in the industry. So this is really for industry, for executives from the industry. And the question is, should we also not only educate the data scientists, but should we also educate the leaders and the people who actually make decisions in those large companies that don't know what machine learning is about. They just heard about AI from the news, and they want to know a little more to actually figure out whether this is something that they should invest in or not.
Okay, thanks, Olivier. So the next question is for Professor Yasser. So continuing on the last reply from Olivier, we want to turn to the very crucial question of developing talent in AI. So obviously, Moroccan universities are very, very interested in developing AI programs to foster AI talent. Now, the question is, how do we actually create a successful AI course or curriculum? Like, at which level should AI be taught? Should it be taught at bachelor level? Should it be taught at master's level? Should it be taught at PhD level? Yeah.
So when you want to learn machine learning, there are the beginning part and the end part in terms of the education. Both of them are critical. And then there is a lot of middle ground where there is flexibility. So the beginning part is to take away the intimidation and to establish the real understanding of what is going on. Machine learning is the victim of its own success in the sense that people can practice machine learning without a lot of background. And this made a lot of people jump into the application without understanding the fundamentals, and that leaves a gap that is really never filled later on. So I always view the right way of designing a curriculum or a course. It would be at the junior, senior level or early graduate level, so between junior and masters. Mm-hmm. It would require very basic prerequisites like basic math, linear algebra, probability, basic programming, nothing fancy. Basically literacy in the quantitative fields. And then the starting course is to lay the foundation of what is machine learning, what are the fundamental limitations, what is the basic logic of the algorithms. It may not be a practical course, at least the first part of it, but it makes people understand what is there to have a solid ground to stand on. And then during that course, you can sample different techniques that are useful and give exercises that are practical in order to make it real rather than just a theoretical thing. I would very strongly avoid what I would call the hard theory, because sometimes theory is useful in terms of relevance to practice. Sometimes it's theory for the sake of theory, without really having any reason to be related to what people will see in practice. And mathematics sometimes gets a life of its own. You follow the path for which you can prove theorems, regardless of whether that path is the practical path or the useful path. So there is a lot to be done in terms of choosing what is the theory to be used in the first course. And you need to pick something that is relevant to practice. And even with, there's wonderful, great theories out there that are mathematically established, but truly irrelevant in terms of someone who wants to become an expert in the field. So that's basically the first course. Let me jump to the last course, and I will explain why. So the last course is to basically throw you into the water and see if you can swim. So it is a very practical course, takes a serious machine learning problem, gives you the data, and lets you loose on it with any tool you can find in the literature. You are on your own. Some people use Kaggle, some people use the Netflix problem, some people use the other ones. Now the idea is that in the first part you got the foundation, and in the last part you became a practitioner. Okay. There is a middle ground which is learning the different techniques. Personally, I find that learning the techniques can be done by the person on their own. Techniques are evolving, they are very well documented. Once you understand what the principle is, you can add. You learn neural networks today, you learn boosting tomorrow. It's an evening. If you sit down in an evening and you understand it. So I don't particularly subscribe to a middle course, although if there is a middle course, it will be good. It's like spoon feeding instead of letting you on your own. But the first part and the last part are very important. Having a solid foundation and making it real in the absolute sense. You loosen that. So not surprisingly, that's how I designed my course. So my Caltech is a quarter system, so there is fall and winter and spring. In the fall, I give the course that is the MOOC that everybody sees. And in the spring, I give a practical course, in this case, based on the Netflix data. It changes, it can change. And in the middle, there are people who do other courses as well in order to become more fluent with it. I would say that in terms of popularity, it's the courses in machine learning are very popular in the universities. The course at Caltech is the biggest at Caltech, even compared to Math 1 and Phys 1 and whatnot. So clearly, people want to learn it, and people come from all types of fields to learn it. And if you do the first part right, and you work on a serious problem beginning to end on your own, you are ready to face the world. The way I would say that you want to, if let's say you want to become a medical doctor who practices, okay? The first part is to take biology, okay? That's my first term. The second part is to go to medical school. That's the techniques. And then the third part is the residency, which is taking a practical problem and working for it. By the time you end, you can practice medicine and you have the fundamentals there.
So some people argue that the first course, especially today, is not that important because you can just run, the available libraries, and you basically get to the applications quickly, and you can get some results. And what's your opinion about that? It's
a long, short term, no pun intended. So if you are interested in the short term, I'm with you. Okay. If I'm in a hurry in order to show results in 6 months, yeah, who cares about the theory? Okay? It catches up with you. When the going gets tough, you need something to fall back on. Mm-hmm. And that doesn't apply only to machine learning, it applies to other things as well. I mean, I was, as a student, I was very serious. I mean, I enjoyed being a student, and I learned certain things that people thought were irrelevant, okay? Every now and then in my research, I can remember something that, and if I didn't learn it, it wouldn't even occur to me, and I can pursue it. So having a solid foundation pays off. It may not pay off in the short term. Mm-hmm. It may pay off if you are in a hurry, but it does pay off.
Okay, thank you, Professor Yasser. So we'll come back now to talk about the region of Africa, North Africa, and my next question goes to Kamal. So we saw in Hussein's slides that this region maybe needs some focus, some special focus, and we know that Google is a worldwide actor. You have efforts worldwide regarding AI. So what are the special focus you have on Africa?
Sure. Hi everyone. So Google's been active in Africa for, I'd say, over a decade. Practically speaking, we're supporting many developers through a lot of different programs, startups. So I think last numbers were like 100,000 developers, 60 startups went through the Launchpad Africa program. We're also, from a product standpoint, we're working to make sure that access to technology works on low-powered phones, that the internet works well, because that's all important infrastructure for development of Africa. We're participating through a lot of events. So I think there were an event in 2017 in Tanzania. There was another event in South Africa. And then we just opened an office in Accra. And actually Fred and I are going to visit this on Friday. And the purpose of this office is to create a center here with people from Africa and to push the state-of-the-art of machine learning and collaborate with the local universities and industries and to create this ecosystem and to reinforce it so that we can foster the African ecosystem. But I want to build on something that Yasser mentioned in his talk. Google provides a lot of things for free. right? So TensorFlow is free and it's open source. So there's two very important things. You can access through collabs to very powerful computation. You can run TPUs, which is the hardware that Google brain researchers and DeepMind researchers are using. It's the same hardware you can use for free. You have tutorials, you can copy-paste code, you have access to the latest libraries that are open source. Now, this is huge. This is huge. And personally, I can relate to this because I was born and raised in Morocco and Maghribi, in Rabat, and I was lucky that I had a computer, but I didn't have the same access to information as my cousins who lived in France, for example, right? I had to wait to get the same books. And I think it's an incredible good news for people who have less access to this information, this compute power for which, don't necessarily have the same economic means. And again, like, there's smart people everywhere, very smart people everywhere. I know my dad used to say, remember that algebra is an Arabic word, it's al-khibr, right? And so I think it's a fantastic opportunity for everyone, in this room to realize you can get involved. You can work on the same problems that people all around the world work on. You could do Monday I was at Google Developer Group in Casablanca, and they were, first of all, they couldn't believe that Google would give away all these things for free, which is interesting. But then, they were asking, how can I get involved? And, you could start getting involved by helping us translate documentation in Arabic. We're running doc sprints. We've had 30 doc sprints all over the world. There's some African languages in which now, TensorFlow documentation is getting translated. There are a lot of open GitHub issues. We launched, I could go on and on about all the things we're doing to, to help you guys get involved and participate to this huge revolution. We want, there's an ML revolution, and we, at TensorFlow, we want to power this revolution. And when we started thinking about let's go in different parts of the world and let's go to Africa, obviously I was like, yeah, let's go to Morocco. And so this is what brought us this week, and I'm very happy to be here. But again, I think there is this huge opportunity that's opening up for everyone in the world, and we're very excited to help power it.
Thank you, Kamal. So I think another company which is doing a lot of efforts to promote AI in Morocco and beyond in Africa, so it's OCP. So Walid, can you maybe tell us more what kind of efforts OCP is doing?
Yeah, of course. So actually we're quite active on many fronts. So we have always been involved with universities and with research. First, because we are a mining company, as I was saying at the beginning of the conference, so we have loads of engineers and in OCP, and AI actually is mainly math and computer science. So the idea for me to add something to what my colleague said is that in a more general way, the question is not only which type of effort can we do to add some AI talent in Africa, but in a more general way, how can we train scientific talents? Because the idea is that if you go to French engineering universities or English engineering universities, you have loads of Moroccans, Tunisians, and Algerians. And the idea is that what can we do to first, can they stay in their homeland? And eventually, why don't they come back to their homeland? So, and AI is just a part of this equation, actually, for me. And so in our situation, what we do is that we try to build ties and strong ties with universities all over the world. We fund this UM6P, and we have a lot of PhDs working on AI projects. And we sponsor this kind of event, and so we're really happy to sponsor events like Nassma, because we strongly believe that at the end of the day, it's not only knowledge which is important, but it's mainly, of course, people. So it's how people can interact each other, how can they meet. And if we want AI to have some sort of impact, the idea is to think about how AI could solve business problems also, and not only AI for the sake of AI, but to say, okay, how, if you have some business problems, how does AI can have any some sort of impact on this business problem. And so the idea is that it's an effort inside the company, outside the company. It's theoretical, but it's also practical. And hopefully in a couple of years, we will see some.
Thank you.
Okay, so I think most initiatives would probably start by thinking about retaining AI talent, because I don't think many people would disagree that there is a lot of talent in North Africa, but it's just about how do we retain it, right? So I would like to ask the question to our panelists, what are the concrete measures one can think of in order to retain our AI talent and to be basically more like to be exciting, so that like Moroccans, for example, come back and like benefit the AI community here. Feel free to pitch in.
I don't know if I should start, but I can start. We face this problem because, again, the center as we're building it is composed of great talents, and so it's really the people that makes the center more than anything else. And so the question that we faced at some point is, how can we attract talents in Switzerland, back in Switzerland, or back in Europe in our case, or extended Europe in that particular. Because again, I mean, I didn't say at the very beginning, but we're about 50 full-time scientists now, and we're still growing, and they were picked out of over 1,000 applications, right? So we received a lot of CVs for those positions. And I think I was talking about hitting a chord earlier in my description, and I think this is what we're playing with. So we're really trying to explain that it's really important now for Switzerland and for Europe to wake up. To wake up in the face of what's happening in the US, what's happening in China, what's happening in other places. And we need to join forces. So the thing between the two schools, for example, ETH Zurich and EPFL, that's almost, that's what makes us unique. There are very few schools out there in the world that will join forces, let alone across countries, to build enough of a critical mass. Right, so you gave the example of the Alan Turing Institute, which is a great example. But now each of the schools that actually contribute to the Alan Turing Institute have, most of them have their own data science center now as well, right? So the question is, how can we, attract people, show them that we're trying to join forces to build enough of a critical mass, that we're attacking societal problems. So you need to hit a chord. You need to, play with the sensitivities of the people. Of course, I'm not necessarily well placed to know what would bring people back to North Africa. And I think there are examples in the room here, and I don't know if they could give us, some examples, yeah. And other people here. But at the very least, in our case, bringing people back to Europe in mass. We played with that sensitive angle, which is, okay, we're trying to join forces. It's between two great schools. We're trying to build a critical mass because we're trying to make an impact. Europe has to wake up. We have to build a data economy. And so that resonates with a lot of people.
Yeah, and just to add something to what you just said, I think there are also some stuff that people don't necessarily realize, is that the reason why you can see some high salaries in the US or in the UK for some AI talents is that because you have some companies whose business model is really based on the algorithm. So for example, if you look at Facebook or Google, if as an employee, if you do something that really improves the algorithm, even by 0.5%, you can have a tremendous impact on the revenue of the company. So it makes sense for a company to pay them a lot of money. So it's really an economic reason, and it's because of the business model of those companies, because they are tech companies. They are like Google, Amazon, Facebook, Netflix. So in Africa, currently, you don't have a lot of those companies. So, so that's the reason why, just in terms of salary, that just explains why you will never see, won't see so commonly AI talents paid as much as they're paid, for example, in the US, because it doesn't make sense economically speaking. But to attract AI talent still and to build an AI community, for me, it will come naturally once we have some first victories. And the idea is that some people will say, okay, I have the choice between living in the US or coming back to Morocco, working on really interesting projects which have an impact, either an economic impact, either a social impact, and I have working conditions which are really attractive. And the people I work with did the same studies that I did, and they share the same mind, and they share the same passion. So it's we need to basically begin a virtual circle. But when we will have our first results, and I can see that more and more people actually want to come back to Morocco to work in quantitative field and to work in machine learning. So it's difficult to say if it's just a noise or a signal. But I think in some years we will see something, and we will see if it's noise or signal.
So let me share my own experience observing international students at Caltech and the pattern of going back home versus staying in the US, which I observed over 30-some years. So when I started, pretty much every international student other than European would stay in the US. And then there came a transition where Chinese students started going back. And at this point, almost all Chinese students go back. And you can think of this and analyze it and say that pretty much people want to go back. I mean, you know, the home has the home advantage, social life and whatnot. So the thing that repels them from going back is the professional opportunity. And when the situation in China, it did not change politically, but it changed economically. It became free market fully. People can have a startup, and it succeeds, and they, you know, reap the benefits of that, and they have a fulfilling, you know, professional life, and that is enough for a lot of people to go back. And there is an avalanche effect, because when you start seeing people like you going back and they are happy, that makes you go back as well. So there is a little bit of a build-up toward that. So I would say that the only thing, or the main characterization that I would say that needs to be in a country for people to go back is that for the professional activity to be real. I'm Middle Eastern, so I can speak negatively about the Middle East without offending anybody, because I'm offending myself. The Middle East is notorious for having projects for show. And people understand that, people recognize it, people smell it, and those who are actually professional and do the work are not going to leave a real professional career to come up for a, you know, huge building and, you know, lots of stuff that really has nothing to do with reality. And it is very difficult to manufacture something being real, because it's cultural. It's a great extent, and people want to have an impact in a hurry, and they are very worried that they have nothing to show for it. So I can understand the dynamics that makes them tilt this way. On the other hand, the absolute key is the freedom to have startups. If you put your conditions such that people can have an idea, they start up, they don't go through the bureaucracy, and most importantly, when they succeed, they reap the benefits. That's a question mark for certain countries, that they will let you do it until you're successful enough, and then they take it away. So if you establish the environment for startups, I know that there are a lot of people who are going to do it, and because they have control over the situation, they don't have to adapt to, you know, norms and cultures and whatnot, and that would be the way. And if you look at China, that's really what happened. People went and started their own, and startups become big companies, like Alibaba in there and whatnot, and they can hire and they can compete with the big players here. So it's a process. It's not going to happen instant, but it actually has to do with change of the environment in the country you want to attract people to, rather than trying to persuade them.
So,
yeah, I agree with that, and I think maybe one thing to think about is that it's becoming a global game, right? And so because this is knowledge worker, right, and innovation, and the tools are actually getting very cheap. And because there's this home advantage thing, I mean, a lot of people in Silicon Valley, they're fantasizing about living in a place where housing is not crazy, where you could see your, you could see your friends, you could see your family, and you could work on what you're interested in and innovate, but you're still doing the same thing. You're collaborating on GitHub, and you're acquiring customers, whatever they are in the world. So there's also a way to think about this, which is why, making it so that people want to stay. And so before, you want to make them, come back, but also if you provide a condition for people who are already here and they can work on their idea and they can reap the benefits of their innovation, then you could have wins, as you mentioned. Then people who are abroad, they will see that and they'll see the proof. Because I imagine those Chinese students, they saw that some Chinese folks were successful, and this is the test. This is, oh wait, something's happening. And so yeah, I think again, as you're thinking about your careers, there's a mental model which is I get my education, I go look for a job, I build my resume, I get a job, and then I get experience. But in the Silicon Valley, like a lot of the way that people are hired is through their GitHub contribution. It's not necessarily to their diplomas. So my point here is you could start looking at getting involved directly, even while you're studying, and start building this experience and start creating value for yourself.
Just to add some elements of reflection. So, of course, I'm not idealistic, but it's been some years now that I live in Morocco. Honestly, a lot of things changed. So you can see that more and more VC deals, for example, in the startup community. So eventually 15 years ago, you didn't have any venture capital fund here. So now you can fund a company, you can try to pitch to VCs, and you can raise money, and it belongs to you so far. So maybe it's not, of course, it's not ideal, and you have so many things to be changed, but there is some dynamic. You can't say that the way things were 20 years ago are the way things are now. This is not the case at all. But it will take time, of course. And for me, in the position where I am, I see things changing, even in OCP and outside in Morocco in a more general way. And I can see that more and more people are coming back. And first, of course, for the lifestyle also, because we have the sun and we have nice people, but also because the projects are more and more interesting, and you feel that you can make an impact. Because sometimes you have some in some places like Paris or New York, you can see also or in London, you have loads of talents in in a short number of companies where competition is really high. And in like in Morocco, you can feel that you can make an impact in what you do. So for me, it's not like black or white. It's you have a gray area.
Yeah, just one last thing that I want to again emphasize maybe is. At least in Switzerland and other places, and in Europe in general, it's not about the startup market, or it's not about necessarily Google or the GAFAs, right? There is the traditional industry as well, and the traditional industry today is hurting. They don't know how to take that turn of digitalization well. OCP is a great company in Morocco, and again, also, these are the companies that should be supported. And North Africa in general has great companies, and the question is, how will they deal with that turn to digitalization? So it's not about creating yet another Uber or other startups like that. It's about how do we deal with the existing economy? How do we help the existing economy take that turn? And that is what I meant by this sensible, it's not about getting rich, coming back to Morocco to get rich because I create a startup that I could have created elsewhere. I think that hitting that chord is about saying, well, I want to help my country, I want to help my continent, I want to help the people who live here by making sure that my country doesn't miss that turn. I think, and Switzerland and other countries, but Switzerland is extremely worried. There are a lot of amazing companies that have been around for 100, 120 years that are still world leaders. And they don't know whether they will still be in business 5 years from now.
So from your answers, what I understand, so the best way to retain these talents and make them come to their home country is to have an AI activity that's making an impact. So my next question is the how. How can we make AI make impacts locally or even globally, but from these countries?
For me, it's just, I don't think the best way to think about it is to say how AI can do things. It's more to say, let's see if AI really solves problems, because in some issue you can see some hype or where people have over expectations about what AI can do. Because, for example, for us in OCP, sometimes people come to me and say, oh, I have this problem, do you think AI can solve it? But it doesn't really make sense because like the way the problem is, you can't solve anything with machine learning in this particular problem. So the idea for me is that once AI will show that on some really some specific problems. So for me, the complexity, so from what I saw, is not in the algorithms. The idea is that when you study math, and that's my case, like all of us here, when you study math, you have the tendency to love complex problems and to think that the value is in the complexity of the algorithm or in the complexity of the problem you're solving. But in reality, not at all. The complexity is how to model the business problem as a machine learning problem. That's this translation which is complex. And once you succeed it, then even simple algorithm can do the job, and you can like eventually improve it likely with a couple of percent. And it's funny, but it's not really crucial. The crucial part is how do you model a business problem in a machine learning problem. And so that's the AI part. And the other part that we must be aware of is that North Africa, because we talk about North Africa, is a small market. So it's something really stupid, but except a small number of companies, you have the ecosystem, the economic ecosystem in Morocco is SMEs basically, so small companies, because the market is small, because it's not easy to expand. So you will see all the AI talents coming back. Also, when you will have bigger and bigger companies, because markets will probably open, and it's going to be easier to do business with neighbors and neighbors in Africa. So it's not only an AI problem. I mean, it's an economic issue in a more general way.
So I agree that right now I think that the world is learning how to use this great new tool, which is machine learning, to business problems, right? So in companies that are digitally native, where everything's digital and you're doing sort of Google's doing search, and you could provide more relevant search to users, like it's an obvious, it's correlated with business. And what we're seeing with TensorFlow is, there's this fundamental property of machine learning that all of a sudden you have this thing that's automated, that's super fast, and that does the task, better than when it's very narrow than a human, right? On computer vision, it detects, defects, or it could synthesize speech, things like that. And so now everyone is like looking, how do I apply this to my business? And the world is going through that learning phase, and which is why like initiative, like what you were talking about, Olivia, are so critical, because all these businesses are experts in their problems, right? And then through TensorFlow, we are experts in the tools. And the platform is a really nice way to connect experts in tools with experts with problems that could be interesting to solve with those tools. And so what we're seeing is that the global phenomenon of, okay, so call center companies are looking at ML and they're like, how can I, decrease my cost, and how can I improve service doing this? Marketing companies are going through all these things. So I think in looking at the lens of Morocco, taking some industries like agriculture, tourism, healthcare is an amazing area of application for AI, and thinking of how you create value. Because at the heart of all these ecosystems, there's value creation. It's the first thing. If you can create value and you make it through automation, so it's like exponential value, then all the rest follows, right? You get funding for education, for talent, you get VC money, industrial interest, people flock because they see job opportunities.
Yeah, just to comment further, I totally agree, and in my own experience, even in the US, when companies approach me that they need help with AI, it's usually a very generic thing. We have data, and we think there's an opportunity with AI because we heard about it a lot. Can you help us? And a big part of my work is that I always try to find a low-hanging fruit in what they do, concrete project, short-term, 3 to 6 months, where they already have the data, and then work with the people there, establish the rapport, so that they actually get results there that are of economic value. And as you said, once there is economic value, people will trip over themselves trying to run towards you. And then from that on, it becomes part of the culture. So it's not only for the developing world. In general, AI is new, and people are excited about it without knowing exactly how to use it. And there is a process where you make it concrete for different entities, and from then on, it's on autopilot. You don't even have to worry about it anymore.
Just to add one last thing, sorry, because you have a lot of AI talents eventually in the audience. Because the way AI is taught makes people think that the complexity is the Kaggle competition, but in reality the complexity is how to build the Kaggle. Basically, you have a business problem, and you're thinking, okay, is there a way that I can build a Kaggle competition that will solve this business problem? This is where the complexity is, because once you have the Kaggle, you send it to the web, and you have a lot of people who are really talented and who have time to solve this issue. So the complexity is you have something, you're making not enough money or you're losing money. Is there a way to build a Kaggle such that if I solve this Kaggle, I solve my business problem? So that's the way to conceptualize what we're talking about, basically.
Yeah, in some sense, I'm hoping, since there are lots of representatives from DeepMind and they are so good at games, I'm a bridge player. I love bridge, and I am yet to find a bridge program that beats me. And I depend on you, but the problem is how to pose the bridge problem into the model. I mean, you still have full information 2-player. Mm-hmm. Try to go to 4-player, please, and send me an email when you do. Okay.
Sure. Okay. So if there is really no. Okay. So we'll probably open the possibility to ask questions to our panelists. So if you have any question, please raise your hand. And a microphone should come to you.
Hello, I have quite a very generic question. So we saw that AI today succeeds to do very specific tasks like playing a game or detecting cancer, skin cancer. So it's a very clear problem. But the human intelligence seems far above this, because when you take a baby, the brain is completely empty, and he succeeds to learn how to speak and how to interact. And at some points, he succeeds also to get consciousness of its own existence. And so I would like to know if you think that machine will be able to do this, and if there is research ongoing about this subject and when it could occur. This is my first question. And the second one is about Professor Yassir told that he was working on the fact to understand why neural network were working, and it was something that is not yet done today. And I would like to understand what is this project that you are doing, if you can give us some examples of what you do to understand why neural networks are working.
Okay, so let me answer the first question, or at least address the first question first, and then the second one, because it's specialized. So artificial intelligence at the performance of being impressive is still new, so it's single task or etc. But I see that it will propagate to multitasks. But even if you look at humans, when it gets serious, we still specialize. People are expert in one field, in spite of the fact that they are able to learn many fields. So I don't see an inherent advantage for being able to do it all, but at least there should be some minimal level to adapt to more than one situation, so you're not, like a one-trick pony, as I mentioned in the other one. So that's my view about it. It's doable. It's probably the next step, but I don't think it's that critical in terms of achieving what we want. We can have multiple experts for multiple fields. So in terms of the other one, which is a technical question, it's a purely technical question in the sense that given what we know, if I didn't see the results, or the practical results of machine learning now, I wouldn't believe that they would happen, because they defy a basic premise, which is the amount of data you need for the number of parameters. So there are a number of approaches, some of them by my colleagues, and some of them that I'm approaching in collaboration with Dimitri Psaltis at EPFL. And some people attribute it to the learning algorithm. So the fact that you use stochastic gradient descent, there is a colleague at Caltech who showed that you converge to the nearest minima, so that becomes like an implicit or self-regularizing feature. It partially explains different things. The angle that I am looking at is when does it work? Because I can see in problems that it works sometimes for certain problems, and for other problems with the same amount of data, with the same architecture, with the same training error. So it's not a failure that it's too complex, etc. You don't generalize as well. And I find that question to be more interesting because it's actionable. After you get the answer, you realize which architectures or which systems to use for which problems. Whereas there is part of it which is pure curiosity. How comes this is working? And when people ask that question, usually they are satisfied with the minimal theory because it's not actionable. You tell me, oh, it's because this and that. Yeah, that sounds right, and it's not going to change my behavior. But this one will change my behavior, so the answer should be indeed pointed, and that's what I'm working on. Very early for me, I don't have results to report yet. There's a question of the entropy of the problem being relevant, and then it's not really the entropy as in Shannon entropy, it's really a linear version of it, but it's still at a preliminary research situation.
Okay, so next question, but please keep the questions within the scope of the subject of the panel, which is AI in North Africa, if possible.
Okay, here. I'll try to do that, actually. Okay. My question is related to the application to put in AI and machine learning into application, especially in the enterprise realm. So maybe Olivier has already touched on that kind of talent churning from the enterprise outside. So there is no doubt about the disruptive impact of AI in kind of revenue generation, process automation, and and optimization. So, but what of the feeling that we get from clients through different engagement, it's that kind of frustration. They actually do not know how to put that into application, what we call into production, how to personalize these stuff into application, saved digital native companies, but most of SMEs and startups are actually facing a lot of challenges doing this. I would like to hear actually your comments on that, if you can elaborate more.
Obviously, I will address it a little bit, and I'd like to hear from my colleagues as well. So pretty much like we said that the students will go back to their home by example when they see successes. There are many cases where the company will be better off when they see examples, concrete examples of success. So it is not a surprise that the state of affairs that you're describing is the current stuff. It's a new technology, and people have not applied it in many places. Okay, so this indeed, what I mentioned about the low-hanging fruit is probably the entry level, and then after that it becomes by example. But when you take this and apply it particularly to North Africa, you can go for wide sectors that have a great potential, and it was alluded to, the healthcare center, not only the healthcare area, not only because it's an important area, but because it's inherently different from region to region. The priorities, the illnesses, the health habits and whatnot. And the impact is enormous. If you do something, people will feel it, the impact in them, sort of the closest thing to their heart. So if you want a culture of applying AI at a wide range in a country, I think healthcare is a very good starting point to sponsor that in terms of initiatives in that regard. And yeah, maybe some of my colleagues will have other comments.
So, well, so far, for me, what I observed in the current situation in OCP is that the challenge is not necessarily in is more how to address the business problem as an AI problem, as I was saying a bit earlier. Then because I'm trying to understand exactly what you were talking about. Are you talking about more the IT issue, or how do you scale the usability of the use case in all the company? Or because once you find the algorithm that solves the problem, then it becomes an IT problem to say how can we use this algorithm in all the company given the system that we have, and it's becoming a DevOps problem, and so for us this thing is not so easy to solve. So, and we have already some applications that work quite well. The only thing is more to say is for the executives. For me, the main challenge to tackle is how executives and business people can have a culture good enough in AI to understand how AI can solve their problems. It's not a technical problem for me.
From what I've been exposed to, at least in Switzerland, and for those large companies that approach us, if a company doesn't have a data strategy in place, they're doomed to fail. And the difficult thing is that, and I don't know exactly what, we could discuss the experience, but finding, if you're given a data set, finding some low-hanging fruits and calling it an AI project is great, and it gives the opportunity for the company to brag about the fact that they're, on the road to digitalization. And what we see in companies is that when they want to brag about digitalization, they have about 40 to 60 such digital projects going on within the enterprise. So scaling out is easy. Scaling up is very difficult. So making sure that in a traditional company, one of those that are not digital natives, scale up, meaning that they bring a digital project to a point where they get the return on investment that they were expecting originally is very difficult. And in Switzerland, for those companies, we haven't seen it yet. We've seen a lot of pet projects, 40, 50, 60, that solves, but if there is no underlying data strategy and push towards, all the way to deployment, making sure you can actually commercialize it, it's a complex thing in the industry today.
Totally agree, and just reflecting on my own experience with bigger companies in the US, the data is a mess, heterogeneous, legacy, distributed between different departments that don't talk to each other, redundant. Nobody sees the value to them by contributing, and it takes really a huge effort from the top down in order to get anywhere, and there is a resistance to that, so I'm completely sympathetic with your experience.
And it's a problem. It's hurting. I mean, or the people in the business units that feel like AI, I heard, is going to replace me. Why would I contribute? Why would I play along with those data scientists who, at the end of the day, will build a robot that will, take my job? So it needs to, there is a need for a cultural change, and it should be that AI can actually help make things better. We're trying a project with some companies of making sure that whomever contributes to the development of an AI project within the company is recognized. So there is a notion of lineage of who has done what, has contributed what, some sort of issues on GitHub for an entire data science project, where even people in the business units can actually be recognized for what they've done and show their value to the project. But it's a complex.
This is true, that's complex. But actually, that's the responsibility of the executives to make communication clear and to lead those projects which are not only technical, that's true, and that mainly are based on people. So people need to understand what you do, and you need to be pedagogical about what you do on an everyday basis, and that actually there is a convergence between the interests of the company and the interests of the people, at least in OCP, that's what we strongly believe.
So from TensorFlow, I think of three things. I think the first thing is, so I was saying, from TensorFlow, I think of three things. The first one is, okay, we've provided this open source platform. We keep improving on the product, but we have to do more, and we have to help the ecosystem organize and recognize that, so we're working with experts. So when OCP is, doing all these incredible, things in Morocco and is also funding this great school, working in partnership and helping, answer these questions, helping with the brand, helping with the documentation, things like that. From the grassroots adoption is working with the community, empowering the community. So I would say that would be kind of a first thing to do. From the product perspective, we're still making incredible strides on the product. So I think yesterday I was talking about 2.0, which puts a layer of abstraction of very large Keras building blocks that you can use, and granted that it's important to know the theory, but then it just makes you really productive. There are other things that, so I think Google Cloud just released AutoML. That's mind-blowing. So what AutoML is it's basically, so AI is like this layer, ML is this layer of neurons, right? And AutoML is AI that figures out the best AI, basically. It's like meta AI. So it looks at all the different kind of infrastructure. It looks at the size of the hyperparameters. It looks at whether it could find other data sets that would help figure this out. And so now it's like, well, you create you get your data, you understand the business problem, you get your data, you put it in this thing, and then it comes back and it says, I found a model for you. I mean, that's mind-blowing.
That's what I was meaning when I was saying it's not a technical problem anymore. It's how to build a data set such that you can use AutoML or some, that's what
the human race is getting very, very lazy. We used to have to solve the problem ourselves, and then we moved to getting a data set to solve the problem on, and then we will just sit down and let the system pick the data set. We'll just do nothing, I guess.
I'm sure there's still a lot of that. And so the third thing, and I think it's more, I find it super exciting for Africa, for Morocco. ML is getting smaller and smaller, and so if you look at telephony, right, there's this mobile telephony kind of in Africa jumped from the step of having landlines into mobile, and the adoption was incredibly fast, and so ML is getting really, really small, and now you have it in the palm of your hand. You can build with TensorFlow Lite an app that lets you, for example, there's a use case about cassava in Africa where you just take a picture of the leaf and it tells you whether it's sick or not, whether you should treat it or not, and that's a plant that nourishes 500 million people a day. You could build that with simple models, and you could bake it into TF Lite and run it on cheap Android phones. And now it's getting smaller and smaller into microcontroller units, so you could think of all the things you could do. People have mobile phones in the palm of their hands, and I think this is something where, mixed with the ingenuity of people, I can't wait to see what people are going to build using these things.
Next question.
Okay. Good afternoon, everyone. My name is Ahmed Omar. I'm an undergraduate computer science and mathematics at the University of Qadi Ayyad here in Marrakech. So I have a kind of 4 questions for both industry and for...
No, that's
what?
too much. Just 1 question, please.
Okay, 3.
Take the most important one.
Okay, the first one for gentleman, Mr. Yasser, for at the courses at the university are very, very boring, kind of boring. You woke up at 7 o'clock to attend the class at 8 with teach you some kind of boring stuff, and even sometimes don't teach you the basics. How to combine...
You know this is recorded, right?
Yes, I know. Leaving some fantastic course at online platforms like Udacity, edX, or even MIT, Oxford, kind of like that. My second question is to the industry.
We'll take just one. Thank you very much.
Yeah.
Okay.
So just to comment this, I think the idea of MOOCs and online courses is great for everyone, because in some sense you have everybody contributing, and then you pick the best or the ones that matches you. That does not mean that the teachers are out of business, because the way the course is taught in the university in a flipped classroom form, where the class time becomes a discussion time and the lectures becomes a video textbook, so to speak, which is very effective. Tried it myself at Caltech. Caltech, they get the machine learning course that you get exactly, except that after that, I have an hour of a discussion with the class. And in my experience, when you are exposed to the lecture in detail, and then it's followed by an interactive discussion, things settle in your mind far better than if you just took it one time in a classroom presentation. So, maybe the boredom of the classes will go away by choosing the more interesting ones. But all I'm saying is this is not an elimination of universities as a teaching tool. It just changes the medium and changes it in a favorable way according to my own view.
So one question from Twitter is what are the funding schemes that work for AI startups? Funding schemes.
What are
the funding schemes that work to fund AI startups?
Well, actually in Morocco, even if it's not really in the scope of OCP, you have more and more VC funds active in Morocco. So for this person who is asking the question, because he's got a startup, probably his business is quite fragile, is not so strong. So if he needs money, if he goes to a bank, they won't lend him money, so he needs to go to a VC.
So at the national level, maybe, is VC the right way to fund startups?
Actually, that's the reason why, because you have always a lag between the reality and the perception of the reality. And actually, the Moroccan government put a lot of effort to ease the investment into startups through VC funds. So the thing is, you need for your startup to have a strong project and a strong business model, and then you need to show that your product is good, all that stuff. So that thing it's not linked to the Moroccan government. Do you see my point?
So this is about the startup fundings, but you could also imagine that Morocco or North Africa decides to invest in an institute, a national institute in AI and data science as well. The funding scheme would probably then be quite different. Might be government, might be the largest industries in the country or in North Africa that would decide to invest. That would give potentially also the stability of the job, which the startup business doesn't give, right? So what we've seen is that with that type of funding in Switzerland, yes, we're spinning off some of the stuff we do within the institute. But we bring a lot of people that don't want to be they don't want to be confined to a lab. They don't want to work for the traditional industry quite yet, and they find this a good transition for them. So we bring a lot of people back, and we keep people in the country as well. You're asking me?
Could you repeat the question, please?
You have, as I was saying, because if we want to talk about all the startup community in Morocco, and you actually have a lot of initiatives which arrived. You need to be patient to see the outcomes, and all the initiatives won't remove the fact that it's hard to fund a company and to build a company and to build a successful company at the end of the day. So you can do all the initiatives you want, and you can build the strongest ecosystem you can, but the rate of successful startups in the US is quite low. So at the end of the day, you will always see people who tried to build a successful company and who failed, and mainly in the US, you can see them a lot of. But some things are happening. That's my point here.
Incubators work very well if they're attached to a university as well. This is a combination that has been successful in a number of places. And given a young university like this one with no baggage, and they are very flexible in looking forward and not, this would be a pretty good addition to have that attached to it, and not restricted to the people in the university, but the interaction will get it to critical mass.
Thank you for the conference. And my question is, I like what Mr. Yasser said, that for practice machine learning and everything, we can use like international platform like Kaggle and everything. And the thing that I want to share with you, like for the statistics shared by Kaggle about the top 10 Kaggler in Africa, most of them, they are from Morocco. More than 5, and especially the top 3 Kaggler in Africa are Moroccan, all of them. So we can say that we have like great and talented data scientists, but the problem is in Morocco that there is a gap between those data scientists and the Moroccan companies. So my question is, how can we build this link of communication between those different communities?
I think if the company feels that this is real and this will contribute to the bottom line, there will be no such hurdle. So it could be a cultural or a perception that maybe this is a separate activity, maybe they're just playing a game competing with others. But I think this is the first I realized that there are so many distinguished Moroccan contributors to Kaggle. That's a big deal. And the word gets out. Things don't happen instantly. I mean, if this becomes a tradition and others go in, it will take, again, a success story to make people pay attention. It's a process. So I don't have a magic bullet here to tell you that this needs to be done. All I can say is that you stick to it, and things happen if these efforts are consistent for some period of time, rather than requiring an immediate reaction.
But for you and your friends, you should definitely meet Ishraq, who is just here and who works in the HR department of OCP. And actually, she's here. So I don't know if it's you or your friends. So you can meet her. And actually, we have data scientists at OCP, and we work with them. And so we are really interested by talents, of course. But we have to keep in mind that the complexity. Like, we have never been confronted to a problem that we couldn't solve because of a technical issue. So we know that the person who will add the most value is not necessarily the best Kaggler in our current problems. But of course, it's better to have the best data scientists to solve the issues than not the good ones. But we are not in a situation where this is the best Kaggler who will solve this issue, and if he's only 10th and not the first one, it will not be possible to solve the problem. This is not our situation now, and actually even in Europe or in the US. So it's just a good signal. It means that, of course, the candidate is really good at manipulating the algorithms. But anyway, so meet Ishraq. She will be really happy to talk with you.
But I think there is, again, this this notion of incubator is not just an incubator for startups, but it's really this human incubator, if you will. Again, this National Institute for Data Science and AI, where the top data scientists in Morocco could actually, be part of and work hand in hand with the traditional industry in Morocco. Because again, there are a lot of such companies that are just not ready to hire data scientists. OCP maybe, it's in a different situation, I suppose, but there are a lot of companies that are just not ready to hire data scientists. Or if they do, the data scientists will be, singled out. He will be the only person in the company out of 500 people that knows anything about data science, and that person will leave after 6-8 months and will find another job. So you need this transition layer, if you will, where you're recognized for what you can do. You don't want to be in a lab. You want to work for real impact on society, which is very different from what a lab does. And so it's a different layer that works hand in hand with the labs and can potentially transition, that's this notion of incubation, that can also transition working hand in hand with the traditional companies in Morocco. And that should have its own funding. That should be sustainably funded, such that, you know, you bring job security. It's not about creating your startup, which is very high risk at the moment. And, you know, so a lot of those people with a lot of skills, they just, you know, some of them want a stable job and still want to contribute to the economy.
They're like now, I mean, it's a global game, so there are a lot of communities, like there are marketplaces where you could just go and there are people who are looking for data science talent. Like, you know, there are a lot of them, like there's Upwork. So, I mean, again, I think there's a lag in this evolution. There's, you know, companies are identifying the areas where ML can create value for them, which is creating jobs. But it's not a Moroccan specific problem. A lot of people around the world are getting better at this, and they're like looking for companies who are hiring for this. And if you want to optimize, you shouldn't optimize locally. You should optimize globally.
Okay, so we'll take one last question.
Hi, I'm Ilyas Bentashfin. I'm PhD student in DNA PhD program here in UM6B. Glad to be with you today. I want to, because that you mentioned now that it is the latest question, I want to talk with another side. What I mean, going to the end with artificial intelligence is very good path humanity is taking, but how can we guarantee that our choice, our innovation are safe? For example, we use AI in healthcare, but can we prove that this intelligence is good for our future healthcare? Second things that I want to ask about AI limitations. Are we going to let AI govern or rule in the next years? How will our vision become to our intelligence? I say human intelligence. I do not want to play the role of someone who is not optimistic, but we have to think from different perspectives to have a clear vision. If we not pay too much when we consider just the advantage of the AI. Thank you.
Okay.
So on healthcare, I could give an example. Right, we just announced the results on applying ML for detecting lung cancer. It's one of the deadliest cancers on earth. It's got this problem that when you have the symptoms, your chances of survival have decreased significantly. And there are a lot of occurrences where people got a scan a year before they had the symptoms, and it might have been detectable, but it wasn't. Furthermore, it's a very time-intensive exercise for the specialist to go through all the layers of the 3D scan to identify the small thing that could become a cancer. Removing the small thing, if that was not a cancer, that was not malign, is a very it's a heavy operation. There's you might there's a chance you might not recover too. So it is a big problem. And so what we worked on is we worked with leading specialists, worldwide specialists, in tagging those images that looked like they would be problems, and we announced a model that was beating, I think, 5 out of 6 of the worldwide specialists. And instead of requiring having the worldwide specialist spend hours in looking at this thing, it does it in second anywhere in the world. So, I mean, personally, I would take that, right? I would want to be able to get scanned and have this thing detected when I have a higher chances of survival. So I think this is the stage we're in. This thing still needs to go to market, right? And we're right at the stage where we're identifying all the impact and the benefits of this incredible invention.
You guys are doing great stuff.
Okay, on that note, we will conclude the panel. We thank all our panelists. Thank you very much. Okay, so there is now a poster session and a light buffet, so please make your way to downstairs, yeah? Okay.